Electric field lines. Let us represent the electric field around a positive charge. We know that the direction of electric field at any point is the same as the direction in which a positive test charge moves. Since a positive charge will repel the test charge, the electric field will be directed away from the charge. If the test charge is placed at various points around the positive charge, we find that the electric field is radial. This kind of electric field pattern can be represented by using arrows directed away from a sphere, as shown. On the other hand, a negative charge will attract the test charge. Hence, the electric field will be directed towards the negative charge. If a test charge is placed at various points around the negative charge, we find that the electric field is radial in this case too. Thus, all the electric field lines are going into the negative charge. This kind of electric field pattern can be represented by using arrows directed towards a sphere, as shown. Let us study the electric field patterns for a positive and a negative charge. We can make some important observations. In both the cases, the field lines are directed radially and never intersect or even touch one another. The direction of the field lines point in the direction in which a positive test charge would move. In the regions far from the charge, the field lines are fewer. If we consider a surface with area A perpendicular to these lines, very few field lines will pass through the surface when it is placed far from the charge. This indicates that the electric field is weak in regions far from the charge. On the other hand, in the regions close to the charges, the field lines are very close to one another. If we consider the same surface with area A perpendicular to these lines, we find that numerous field lines pass through this surface when it is placed close to the charge. This indicates that the electric field is strong in regions close to the charge. Also, observe closely that any field line is perpendicular to the surface of the charge. Moreover, a charge with a smaller magnitude will have a weak electric field, and a charge with a larger magnitude will have a strong electric field. If two imaginary surfaces are considered to enclose two different charges, the surface that encloses the charge with a larger magnitude will have more electric field lines passing through it. In other words, the number of field lines passing through a surface is proportional to the charge enclosed by the surface.
Starting to feel it? Now go master it with maskitv.